In this video, we're going to explore voting gates, and we're going to look at the behavior of a system in a fault-free environment with a voting gate and the equivalence in an RBD configuration. So we have this voting gate, and we have four elements that are all made out of the same failure distribution. It's a Weibull 2.8/8000 two-parameter Weibull. And the same thing has been reproduced into this parallel configuration on the RBD, and there is a parallel between the blocks in the RBD and the event in a fault tree. Likewise, there is an equivalence between the voting gate in a fault tree and the node in the RBD. What we want to see is what voting criteria we need to set for a fault tree and in an RBD to get the same results. So we'll start with a fault tree. We have a 1 out of 4, and we can change this voting criteria by double-clicking on the voting gate and changing this number. So we'll start with a voting criteria 1 out of 4. What it means, one failure will be sufficient to activate the voting gate. And we want to see what the results are going to be at 5000. The same thing will be calculated in the RBD configuration. So we calculate the results at 5000 in terms of probability of failure, and we have a 0.657955. We go into the RBD configuration, and the RBD configuration works in terms of probability of success or sequence of success. And if on the other side we have one failure is sufficient to fail the voting gate, here we need to have all units operating to guarantee the success of the information being transferred from the starting block, the null block, to the node. So we present the results directly on the screen. Similar in terms of setting is similar to the fault tree, and we can see the results. The probability of failure at 5000 is exactly the same number that we got in a configuration of the fault tree 1 out of 4. So we change the setting, 1 out of 4, we're going to change it now to 2 out of 4. 2 out of 4. And we go back to the RBD, 2 out of 4, which means that 2 units are sufficient to break the break the top event, to break the voting gate. And on the RBD, it means that we need at least 3 operating. So we change the setting of the node to 3 unit operating, and we calculate the results at 5000, and we got 0.237, and we check if the setting is correct on the fault tree, and the result for a 2 out of 4 is exactly 0.237. So we change now to, we're still in a sort of voting criteria, and we change the setting now. We need 3 failures to activate the voting gate, and that's equivalent to 2 unit, at least 2 unit operating on the parallel configuration. So we set 2 unit out of 4, we calculate the results, and we have a 0.042888, and we check on the fault tree, and we have exactly the same results. And final, we want 4 units to break, and that's obviously is equivalent to a pure parallel on the RBD, because it means we need at least one of them operating. If we need 4 to break the system, we need at least one of them operating on the RBD configuration. So we change the node setting to 1, and we calculate the results. So the result in terms of probability of failure at 5000 is 0.003063, and the same results we get it on the 4 out of 4 voting gate. So we can see how we can create the same scenario in terms of voting, in terms of a fault tree using the voting gate, or in terms of a RBD layout using the node. Obviously, we have to be careful because we've got to think about how many units will cause the failure to the system, and on the other side, how many units will guarantee the success of the system. So that's why the numbers are not exactly the same. Thank you for watching.